You know that feeling, right? One minute your AI assistant is a total genius, and the next, it's just completely, confidently wrong. Well, the secret to making AI smarter, more reliable, and actually useful with your specific data is a technology called Retrieval-Augmented Generation. We just call it RAG. It's really the engine powering this next wave of truly intelligent applications, and we're about to break down exactly how it gives AI a perfect memory.
All right, so here's our game plan. First, we're going to talk about the big problem with large language models, why they can be so forgetful. Then we'll introduce RAG as the ultimate library card for AI. After that, we'll pop the hood and see how the RAG machine actually works, step by step. We'll also look at how it's evolving from a simple tool to a supercharged system. And finally, we'll understand why RAG is pretty much everywhere you look in AI today.
So let's start with large language models, or LLMs. Look, they are absolutely incredible. They can write poetry, debug code, draft emails, but for all that brilliance, they have some really fundamental flaws that can make them, well, pretty frustrating to work with. I mean, we've all been there. You ask your chatbot about something that happened yesterday, and it just gives you a blank stare. Or even worse, it confidently makes up an answer that sounds completely believable, but is just flat out wrong. This isn't some random glitch. It's a core challenge baked right into the technology itself.
Let's really dig into these problems. First, an LLM's knowledge is basically frozen in time. It's trained on a giant snapshot of the internet, and its knowledge just stops at a certain date. Second, they hallucinate. And that's a polite way of saying they just invent facts, figures, and sources, and they do it with such incredible confidence. Then there's the black box problem. You have no idea where their answer came from, so you can't check their work. And maybe the biggest issue of all, they don't know your data. Your company's internal wiki, your personal documents, the stuff you actually need answers about.
So, how do we possibly fix this? How do we give these brilliant yet forgetful models a perfect, up-to-the-minute memory? Well, the solution is this really elegant framework we've been talking about, Retrieval-Augmented Generation, or RAG.
At its core, a RAG is a really simple but incredibly powerful idea. It bolts on an external knowledge base to the LLM. Think of it like this. It gives the AI the ability to go and look things up in a library before it opens its mouth to answer you. It combines the reasoning power of the model with the factual grounding of a search engine.
Here's the best way to picture it. A standard LLM is like a brilliant student who memorized a whole library of textbooks, but all those books are 5 years old. Now, a RAG-powered LLM, it's that same student, but you've just given them a live internet connection and a key to a specialized modern library for every single question they get. They're no longer answering from a faulty memory. They're answering from cold, hard evidence.
Okay, so the concept makes sense, but how does this machine actually work under the hood? It really boils down to two main phases.
First, you have an offline process called indexing. This is where we do all the prep work. This is where we build that specialized library for the AI. And then you have the live process, retrieval and generation. This part happens in real time every single time a user like you asks a question.
Let's start with indexing. First, we load up all of our data, PDFs, websites, you name it. Then comes a really critical step called chunking, where we break down huge documents into smaller, meaningful pieces. After that, we use something called an embedding model to turn each one of those text chunks into a long list of numbers, a vector, that captures its true semantic meaning. And finally, we store all of these vectors in a special kind of database, a vector database, that's built for one thing, finding the most similar vectors at lightning speed.
Okay, so now for the live show. When you ask a question, your query also gets turned into a vector, just like the documents did. The system then instantly searches that entire vector database to find the document chunks that are most mathematically similar to your question. It grabs these top-ranked, super relevant chunks, bundles them up with your original prompt, and sends the whole package to the LLM. It's literally telling the model, hey, answer this question, but only use the information I'm giving you right here. And that's how you get a final answer that is accurate, relevant, and grounded in actual data.
But here's the thing. RAG isn't just one simple little pipeline anymore. It has evolved, fast. It's gone from this straightforward technique to a really sophisticated and flexible system that can solve way more complex problems.
And this image shows that evolution perfectly. We started with what people now call naive RAG, that simple, linear process we just walked through. But today, we're in the era of modular RAG. Now, all the different components can be swapped out, rearranged, and souped up to create these powerful, almost agent-like systems that can actually reason and plan their next move.
And just check out all the different flavors this comes in now. You've got Agentic RAG, where the system can decide on its own to rewrite your question to get better search results. There's Multimodal RAG, which can look at an image, listen to an audio clip, and read a document to answer one single question. There's even Graph RAG, which can understand the complex relationships between your data points. We are way beyond the basics here, and it's moving incredibly fast.
Okay, so this brings us to the big question. Why is this one specific technology gone from a cool research idea to the absolute backbone of modern AI in the enterprise world?
Well, this number really says it all. Industry estimates suggest that a huge majority, something like 60% of real-world production-grade AI apps are built using RAG. This isn't just hype. It's the proven, practical, go-to way to build reliable AI that can handle custom, private information for just about anything.
And this table just makes it crystal clear why RAG is so essential. It has a very specific, very important job. You see, if you want to teach a model a whole new skill, like how to write in a certain person's style, you'd use fine-tuning. If you just need a simple, one-off answer, a good prompt is enough. But if you need your AI to be grounded in a specific, constantly changing body of knowledge, like your company's sales data, RAG is the only tool for that job.
And that leaves us with a pretty wild final thought. As these RAG systems become more agentic, able to decide for themselves when to search, what to look for, and how to combine different sources, that clean line between just finding information and actually creating brand new insights starts to get really, really blurry. We're not just building AIs that find answers anymore. We're building AIs that can construct genuine understanding. So the real question is, what does that future actually look like?